Hi, everybody, and welcome to 40 and 40, where we'll go through 40 hydronic boiler installation tips in just 40 minutes. It's nice having this virtual presentation, and I've been allowed to do this by the Eastern Energy Expo and our good friends at the OESP. My name is Steve Wieland. I work for NTI Boilers out of St. John, New Brunswick, Canada, and I've been with them for now almost over 10 years. It's been a fabulous ride. I've been quite enjoying it. Any questions you have, please feel free to contact me. I will tell you that I started as a master plumber back in the late 70s, early 80s. I've owned 2 supply houses since I sold my plumbing business. And I worked for Roth in between. Some of you may recognize me from Roth oil tanks. But now I work for NTI. Probably the best move I've ever made in my life. NTI, products you need from people that care. We've been making boilers since 1967, and here in the United States, we offer a wider range of all modulating condensing boilers and water heaters. And today, we're going to do 40 and 40. We have 1 minute for each slide, which will be quite challenging for those of you that know me, because you know that I could talk for 10 or 15 minutes easily on just one slide. So we'll do 40 and 40. Please hold all your questions until the end. Well, heck, you better email them to me because this is being virtually done. This is made to be both informative and humorous. I hope you quite enjoy our trip together while we're going through 40 boiler tips in just 40 minutes. So let's move it on. Let's get to boiler tip number 1. Learn to sell. You know, the biggest problem we have in the world is people don't know how to sell. I know you might find this amazing. Oftentimes, I've been in a position where I, as a homeowner, have had a contractor come in and bid something for me for $15,000. And I may respond to him and say, you know, your competition is at $12,000. See, at this point, if he lowers his number without changing anything, he's a thief. For no matter what he did, he just lost 100% confidence from me. I've got nothing on him. I am now not going to use his bid at all. Now, had he come back to me and said, gee, Steve, is your contractor going to do this and this and this? Or maybe yet, gee, Steve, I can meet their number, but what would you like me to take out? See, now you have my attention. Now I can say that I would love to work with you. 90% of all contracts are signed not because of the lowest price, but because of confidence in the contractor. So please build confidence, sell your business, sell your reputation, sell your job, and for God's sake, don't cut your prices. Know the company you're buying from. Yeah, you got to know your wholesaler. 24 years in the wholesale business, I can tell you that people bought from me, not because I had the lowest numbers, not because I had the cheapest prices. They bought from me because I had inventory, because I had service, because I carried the parts for the products they purchased. They knew me and knew my reputation, and I still hold, after all these years, a lot of the same customers still work with me today. Know your manufacturer's rep. Almost every wholesaler out there, and especially in the boiler world, has boiler manufacturer's reps because God knows I cover 6 states. I can't be in all 6 states at one time, but I have 3 manufacturer's reps, totaling well over 100 people covering my territory with me. We have technical guys everywhere. They know the product. They've been trained in the product. They know how to work with you and how to help you out if you have a problem on a job. They're dependable. You got to know your rep and then know your manufacturer. How long have they been in business? Have they been dealing for over 50 years? Do they have a great product? How's their reputation? For God's sake, you can go on the internet and look up reputations, but all you're going to read is bad stuff because nobody ever puts a positive review out on the internet. But know them, know what they have. How long have they been in business? How are they on parts? How's their warranty? Do they stand behind their product? Are they like NTI and they have 7-day-a-week, 12-hour-a-day technical service with guys that actually know what to do and how to work with you? Know all 3 parts of the chain. RTFM first. The picture of this van comes to me because I took it in Brooklyn while I was doing a boiler training on the street in front of a wholesaler in Brooklyn. And this guy pulls up, jumps out of this beautiful shiny truck. He walks over to me, gets right up in my face, forgets everybody else in the room, comes to me and says, "You make a wonderful product. Don't stop. Please don't stop making such beautiful boilers." And I tell everybody when I go into their boiler room to help them solve the problem that I'm $250 to get here, $250 an hour, or what would be $500 for the first hour. You could save your money if you just went out, read my license plate, and followed it. Let me zoom in for you. RTFM first. What's it stand for? Think about it. Oh, yes, it stands for read the effing manual first. And then you wouldn't have any problems, because we find that 98% of our problems are caused by installation. When a company like NTI, we test 100% of our boilers, run them, calibrate them, test them, run them through 5 or 6 cycles. When it left Canada, it was a working product. Just read the manual, you might get it right. I love this. The past, the present, and the future walked into a bar. It was tense. I love it when I walk onto a job site and people say to me, "You can't tell me how to do this. I've been doing this for 40 years. I'm not changing the way I do it." And I like to tell them, I've been doing it for over 48 years, and I've learned all sorts of new things. Oh my God, that's the next 36 slides. It's amazing. Learn the new stuff out there. Learn new ways. You might save some money, and you might give your customers a better product. Take time for continuing education like you are right now in training classes. Every manufacturer I know offers you lots and lots of education. We have it locally. We now have it virtually thanks to COVID. We have seminars, we have webinars, we do live training, we do online, we have live fire trucks. For God's sake, get training. And if you're not looking for boilers, go to Takeoff, go to B&G, learn from my buddies. They're all running webinars, folks. Califfi's running webinars. Bob Rohr, one of my good friends. Please go to webinars. Take the time. Take 45 minutes and go through it just like you are right now. Thank you for coming, by the way. Pay your knowledge forward. You know, for every 10 people we lose in this business, either through retirement or possibly this way, COVID-19, we only gain 1. Why? Because when I was growing up, I was never told how to do things, because my boss thought when I was 14 years old that he shouldn't teach me anything, because if he did, I could leave and start my own business and be in competition with him. Well, for God's sake, folks, pay your knowledge forward. Train some guys. Take a guy who's lost his job, who's just good and handy and mechanical. Teach him how to do what you do. Who knows? Maybe you'll find somebody who's going to buy your business when you want to retire. Embrace all the new technologies out there. Embrace smart thermostats. Embrace Wi-Fi boilers. Embrace touchscreens and condensing and modulating boilers. Carry a tablet. Get rid of your flip phone. For God's sake, get a smartphone. Get up to speed and embrace the new technology. It is absolutely wonderful, and it makes our life easier on a day-to-day basis. Do a heat loss calculation. How many of you are still going into the job using what I like to call the finger lick method? You lick your finger and you go up to the rating plate and you clean the rating plate off and you call the wholesaler and you say, "I need a 180,000 BTU boiler." "Oh, you only have a 150 or a 200? Oh, you better give me the 200 because I don't want to undersize it." Folks, I started doing heat loss by the IBR method back in the mid-70s. Pencil and pen, pencil and paper, pencil and paper, on and on and on. And you know, when we got all done doing all these extreme and exact, what we thought were exact calculations, we still added 20 to 30% infiltration and 30 or 40% for safety. All your boilers out there are more than twice the size they need to be. Hell, in my area, we only have to design to 14 degrees. I used to design to 0, adding another 20% onto my boilers. This is huge. Please do a heat loss. You know, if your boiler is twice the size it needs to be, it's running at 50% its efficiency. So you put a cast iron on-off boiler into someone's house. If you exactly size it for a 14-degree day in Philadelphia,
if you're in Philadelphia. That means when it's 39 degrees out, you're only going to be running at 40 some odd percent efficiency because of short cycling. A modulating condensing boiler's not going to do that, but that's no excuse to not do a heat loss. Get right soft. There's Slant Fin has free programs. There's expensive and inexpensive programs out there. Don't go by the rating plate. Stop counting radiation. Do a heat loss. Put in smaller boilers. Do a complete material takeoff, including the piping layout. So when you go back, you have the right material and everyone on the job, or possibly you're the one who took the material off and you're not the one on the job. Give them a map as to what you figured out. Give them a drawing so they know what they're doing. Make it quick, make it simple, make it so you're not wasting time going back to the wholesaler, because we all know our guys go to the wholesaler and they're at least an hour inside, either waiting in line, having a cup of coffee, watching the latest news, talking to their friend at the counter. Please, material takeoff, do it completely, do it right, and give them a map as how to do it. Pre-assemble as much as you can. This is a huge time saver, huge time saver. Think of this. You can send your guys out with modular panels. They can go out, hang it on the wall, clip it together today with ProPress, zip, purge, fill, run, calibrate, and get the heck out. Makes it very easy for people to get in and out. Huge time saver. Flush the system before you remove the old boiler. Get all that crap out of the system. I'll show you more later on this. But we all know that magnetite sits in wet legs of cast iron boilers. We all know it's just dead rust. We call it magnetite, iron oxide, whatever you want to call it. It's magnetic. It will kill boilers. It will kill tube sheets. It will crack sections. It will destroy condensing boilers. The smaller the heat exchanger, the worse it's going to affect the boiler. Please, for God's sake, flush this system before you take the old boiler out. And of course, make sure you put down tarps so when you take it out, you're not putting that black stuff all over the floor. Purge the system. Purge it well. This is this is a job ledger on the amount of time it takes to purge a system. It's amazing. Fill and test the system for leaks. Complete any details of the installation. Adjust the firing device and test all the controls. Pick up all the unused material and return to the shop. Wow, I can remember when I used to purge boilers. I was never taught how to do it. I was taught how to get 2 buckets, a hose, a cigar, and a 6-pack of Pony bottle Rolling Rock beer out of the truck. 2 buckets, and the end of the hose, the cigar, and the beer was for the master plumber. I went in with the working end of the hose to purge it. He'd put the hose in the bucket, turn the other bucket upside down, sit on it, light a cigar, drink his beer, and watch for micro bubbles as the hose was submerged into that bucket. If you use a white bucket today, you can actually even tell if there's magnetite still in the system. Take the time to purge the system. If you don't want to take all that time, which you should do, use expensive air eliminators. Yes, a Takeoff air scoop will do the job if you have 18 inches of straight pipe before it. Yes, never done, only way they work. Microbubble air absorbers don't care how much straight pipe you have before it. They make them in vertical and horizontal. Everybody makes them. Spirevent, Takeoff makes them. Hydrotherm, everybody makes these things. They're phenomenal. They'll take all the air out of the system. But if you use one, make sure that all the caps on all your little can air vents are tight. Otherwise, that air-free or that air-robbed water is going to seek it out and actually pull air in through your air vents. If you're not sure about that, or if you want to leave the caps off, Cliffy makes a nice little anti-siphon device, a little check valve that you stick underneath all your air vents, and it'll prevent it from pulling air back in. Otherwise, they will pull air in using these air eliminators. And remember, when you explain these to your customer, explain how they work. They might be enthralled that you're going to increase their efficiency of transfer 30%, reduce the noise in their system, and not have a callback due to air. Clean and treat your water. I always thought this was something like looking for Elvis. Dan Holohan wrote about oxygen infiltration, an article years ago that was entitled Looking for Elvis.
I never thought for an instant that you needed to clean and treat a system. I can tell you without a doubt, it has to be done for all boiler installations. Cast iron, aluminum, copper fin, I don't care what you have for a boiler, stainless steel condensing, it needs to be flushed and cleaned and then treated. F5, number 5 from 80, X400 from Sentinel, all great products. You put them in the system. They come in jiffy cans now. You screw the end on the hose bib, open the hose bib, squeeze the trigger. 1 can good for it will treat 26 gallons. With heat, it will take 4 hours. Without heat, 4 days. After 14 days, everything starts to settle out. All this product does is take all that stuff that's in solution, laying out in the pipes, and gets it into solution. Makes it all murky. Makes it look like low tide. All that crap's in the water. Yeah. And then you flush it out within 14 days. Think of this. You take your material takeoff, and while you're doing that, put in your cleaner and let the circulators run. Then when your guys come to install, flush it out. After you fill it, put in your protector. Your F1, your X400, your number 1, whatever you're going to use, put the protector in. However many cans you used of the emulsifier, you put into the protector. And if you're like me and you like belts and suspenders, well, I don't wear them that way, but I like to make sure I have double safety. Use a magnetic filter on the return. I've seen these on systems that have absolutely no cast iron except for the pumps in them. Everything else is PEX and brass and copper and stainless, and still after a year have all the collection of all the magnetite on the magnet. This will protect your boiler. This will protect your ECM pumps. Buy them. The one all the way over to the right is actually a product that's portable that you can plug on this system and circulate your system through it and take it away when you're done. The rules of economics will never outweigh the laws of physics. Isn't that classic? I love that. You know, only a rich man can afford a bargain. You cut corners, it's going to bite you in the butt. Please make sure that you're giving your customer what they pay for and don't cut corners. Just because you're going to spend $150 on an air scoop or $200 on an air scoop instead of $50, don't take it out. Put it into the job, build the confidence in your customer. Size your circulators. Yep, it's all about GPM and head. The day of putting in the hugest pump you can put in and turning it up as high as you can so you don't have a turn back is gone. Save your customer money on electric besides fuel. For God's sake, do your sizing for your circulators. If you're unsure how to do it, just go over to takeoffhvac.com and watch the webinar that Mr. Halldorf, Dave Halldorf, and John Barba and Rick have put together just for you to see how to size your circulators. Stop guessing and putting in the biggest circulator so you don't have callbacks. Please, it'll make the system more efficient. You'll get better heat transfer and you'll save the people electric. Outdoor reset will create equilibrium in the house. You know, we design our systems the coldest day of the year. So here in Philadelphia, we designed to 14 degrees, at which point we're really only there about 16 hours a year. And it's not 16 hours all in one day. It's at sunrise for 16 days. Pretty easy, right? Why am I putting 180 degree water into a system when it's 50 degrees out? You know, because we get our energy from oil or gas. We turn it into flame, still energy. We take that energy, now heat, transfer it into the water, still energy. We take that energy as heat and we take it out to the system through baseboard or radiant tubing or fin coils or convectors or radiators. It's all great, but we're trying to make up for the amount of heat going out of the house by putting more heat in. For the amount of energy going out, we need to put the energy in. The colder it is outside, the faster the transfer of heat. The warmer outside, the less the transfer of heat. Outdoor reset will save you 14%. I've done this with Techmark controls since the 80s when I first saw them with cast iron boilers. I do it today using modulating condensing, high efficient boilers that come with outdoor reset. Learn it. And for God's sake, stop taking the outdoor sensor off because people were complaining that it was getting too cold. And stop setting them at 180 degrees and letting them run there. Please use the outdoor reset. It will save your boilers. It's less stress. And for God's sake, it will save them money. So please learn it. Learn high and low voltage. You know, as a plumbing and heating guy back in the 70s and early 80s, I never knew voltage. I used to hire an electrician back then for what was twice the hourly wages I was making, just because I was afraid of electric. But you got to learn it. And if you let the smoke out, of course, it gets very expensive to put the smoke back in. We do have bottled smoke available if you want it. You can pump it back in. Special pump, it's a few $1,000s. Just call me or send me your control and I'll pump the smoke back in it and send you the bill for it. End switches save lives. Anytime we can isolate thermostats from boilers, relays from thermostats, anytime that we can have different voltages and separate them with an end switch, you're guaranteed that there's not going to be fighting at transformers. So please use them. Learn RIB relays. You can switch low voltage things with high voltage. You can switch high voltage things with low voltage. It's an isolated end switch inside, and they're inexpensive. Learn and buy Takeo and Argo relays, for God's sake. B&G and Honeywell have them. They're huge relays that you don't have to learn your wiring. You tie the thermostat into one end, your circulators, your zone valves in the other. There's an isolated end switch. Go back to the boiler, learn them, buy them, get them. Save time, save money, and do it right the first time. Save electricity as well as fuel while providing higher comfort. Yes, I have to go to Circulators Anonymous. I do. I have to raise my hand because I learned how to zone with circulators. Johnny Barba beat me to death on this. Please, variable speed circulators save energy, and low volt draw zone valves like the new Takeo valves are phenomenal. You know, the original Takeo valves drew almost 5 times as much energy and drew it all the time as compared to the new ones. Honeywell's zone valves, the V8043F draws almost twice what these do. Plus, they're powered all the time, whereas this zone valve is powered open and then powered closed. So it saves energy. Meanwhile, your circulator is increasing and decreasing its speed based on the number of zones open. So when it's running slower, it's saving more money, and it's quieter on the system and transfer better heat. So not only are you saving electric, but you're saving fuel. Learn to use the new variable speed ECM, Delta P, or change in pressure pumps. They're phenomenal. Stop selling comfort by the gallon. God, I heard selling comfort by the gallon years ago. You know, when I was back in my apprentice days working with oil dealers, we used to install the boiler for free as long as the people gave us an annual contract. We put in boilers with summer winter hookup that ran 24/7, 7 days a week. We always put in the next larger boiler because my partner at the time, his thought was, why screw up? Why make a $5,000 mistake? Just get the next biggest one. Isn't that a great way to think? Yeah, let's go back to the efficiency ratings that we talked about earlier, right? Stop selling comfort by the gallon. Take heat loads, put in the right size boiler, variable speed boilers or modulating boilers, put an outdoor reset, and gain the trust back in it. Please, you can do it with oil-fired boilers. You can do it with regular cast iron gas boilers. And for God's sake, you can do it very easily using a modulating condensing boiler. Use indirect water heaters. Yeah, get rid of those coils. Take out that L8124 and put it in an L8148. Get rid of the coil and put it in an indirect water heater. That way the boiler can sit idle until they need hot water to be made back in the tank. Indirect water heaters have less than a 0.5 degree drop in temperature an hour. They lose nothing. You can't even begin to imagine how long. I went on vacation, turned my boiler off so that my tank couldn't run, came on, turned the switch on 2 weeks later, and my boiler didn't come on. Not because it was busted, but because I didn't need heat until the first kid got a shower, and then it ran. They're amazing. Save a ton of energy and give an immense amount of hot water, and you don't have to worry about hard water. You just run it through it. If you have water that's very corrosive, be careful of what you use, and you might want to think about installing electric anode rods on indirect water heaters. Most do come with a lifetime warranty, and it is limited, meaning you go through 3 or 4 tanks and they're going to come back to you and start wanting water samples. Primary, secondary piping, you've been doing it all your life. When we used to take those huge cast iron boilers out and put in little teeny weeny 68 series Weil McLeans, teeny weeny Weil McLeans, right? It's pretty funny. You know, you had these 3 and 4 inch gravity mains, and all that cold water was coming back. and it was coming back to that back section and warping it and making the nipples or the rings leak or cracking the back section. It was horrible. So how do we get around that? We put a bypass on it, didn't we? Isn't this primary secondary circulation? Because if we think of the definition of that, when the boiler can have one flow and the system have another flow, that's primary secondary circulation. And all we did by putting the bypass in is bypass the boiler so the boiler could get out of condensing mode and get up to temperature, and the system could come up on temperature slowly so things didn't tick, 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 tick all over the place, and everything worked harmoniously and the boiler didn't condense because you didn't want a cast iron boiler to condense. But today, we want our boilers to condense. So now we do primary, secondary by 2 closely spaced T's. The 2 T's are so close, 4 pipe diameters, that there's no pressure difference between them. So no water will go through there if the circulator on the boiler's not running. So it gives you true isolation where the boiler can have its flow to keep it clean and keep it so it doesn't percolate, and the system can have its own flow. The system can be at a 20-degree delta T while the boiler's at a 35-degree delta T, so the boiler can stay in condensing mode longer. The system can come up to temperature slower, use outdoor reset, and the boiler can modulate. Closely spaced T's are phenomenal. Here we have a boiler that's on the primary loop. Circulator for the boiler circulates around the loop, and when it gets to each one of those T's, it doesn't get anywhere close to it. Isn't that great? Yeah, the 2 closely spaced T's is because the water in that main loop can't sense a pressure difference, so it won't flow to that zone unless the circulator comes on. For more on this, I strongly suggest that you buy yourself and everyone on your staff, if you don't already own it, a copy of Pumping Away, a book by Dan Holohan that I read years ago that changed my life when it came to hydronics. I love this book. Buy it. It's inexpensive. It's online. Go to Amazon.com. Go to heatinghelp.com. Buy the book. Buy it for all your staff. Buy it for any new guy. You'll learn a ton. Buffer tanks. A lot of people love them. I like them in certain installations, not all installations. But a buffer tank not only separates your system so that your system can have one flow and the boiler can have one flow, but also gives a place for any dirt and sediment to settle out, the air to come out of solution, and allow a place for your boiler to be able to run for at least a 10-minute cycle so that it's not always going on and off, or what we call short cycling. There's a little formula at the top on how to size a buffer tank. Believe it or not, the proper size buffer tank is not always 40 gallons. I've sized them to as little as 10 gallons. I've sized them in as large as 120 gallons. Size them correctly, use the formula. Sealing expansion tanks don't leak. I love it when I used to be sent out to a job to change a tank and put in a diaphragm tank because the sealing tank was full. This is done because of gravity feed. Gravity feed? Yeah, the hot water goes up the pipe to the tank and the cold water comes down to the system. See, expansion, the hot water goes up, cold water comes down. But when the water cools in that tank, the colder a liquid is, the more soluble gas is into that liquid, which means that when that water chills in that tank, it absorbs some of the air in that tank. So as the cold water is coming down and the hot water is going up, the cold water comes down to the system, boiler heats it, air goes out of the system, but nothing's there to put the air back into the tank. Yes, sealing tanks don't leak. I'm not saying it's not a bad idea to put in an Amtrol tank, but sealing tanks rarely leak. Size your expansion tank correctly. I still use today, and still at my desk, I still use the chart that's on there that I copied to put this slide up. It's a quick and simple. It's easy. A number 15 Amtrol or a number 30 Amtrol tank doesn't fit all installations. You have to take in consideration the volume, which is why that formula is there. If you go to www.amtrol.com, they actually have a sizing program that you can size in seconds the size of your tank. You need to know the water volume, you need to know the BTU, plug it in, know your temperature. You know that after the water gets to 130, it expands much greater. If your system's only going to be 130 down, you might be able to get away with a smaller tank. You can never oversize a tank, but you can undersize a tank. Do it right the first time. Backflow prevention and low water cutoffs are national code. I can't believe how many boiler systems I go on that just have a regular S1156F still on them, and I can't believe how many boilers I go on that still don't have low water cutoffs. Please, they're code. They save lives. Low water cutoffs will save boilers from burning up. install them. If there's no place on the boiler to wire it in, break the 120 volt feeding the boiler through it. And backflow preventers prevent your boiler water to go back into the potable system. But if you read, and if we had read from the beginning the installation manual on fill valves, we would have found out we should have been shutting the valves off before and after them anyway. The reason for that is, how else are we going to know there's a leak? And if there's constant fresh water coming in, then we have constant magnetite happening. We get constant sludge into the boiler. We get constant filling of the wet legs. We have constant corrosion on the heating surface. Turn your fill valves off. Radiant floor must be designed. There's no rule of thumb. I had a guy call me last night, as a matter of fact. He says, how do I size the amount of heat I need for my radiant floor? I said, what do you mean? He wanted to know how to size circulators and do this. They put in half-inch packs at 300 and 350 foot lengths. This is going to take huge high head pumps. Very little flow, but huge high head. This is amazing. Please size your systems, or have your manufacturer's rep or your manufacturer size and design your radiant. It's an integral part of the system. This isn't a $100 screw up. This is tens of thousands of dollars of screw up. Once the tubing's in the concrete or between the floors, you're not changing it. Please design it correctly. Treat your water. I don't mean take it out to dinner and take it to a movie. No. What I'm talking about is treating it like I showed you earlier. Clean it, flush it, treat it so that this doesn't happen. This is a water tube heat exchanger that is filled with magnetite. That's that black iron stuff that we get on our hands that smells like crap. Oh my God. Yes, the system was full of it and they weren't moving the system fast enough. Let me zoom in on it. That's hard as concrete. And you know how you know this is happening inside your modulating condensing water tube boiler? Because it percolates. That's when it's light. It just percolates. It percolates because of the steam explosions happening inside that magnetite that's hard as iron. The water absorbs into it during the off cycle. When the boiler starts up, it creates steam pockets, which will erode the stainless steel and eventually make a leak. But it also happens on water tube or fire tube boilers. Fire tube boilers, everybody loves them. Larger mass, you know, they're less cleaning, lower head, phenomenal. We carry both. We make both. They're both lovely. They both work great when applied correctly, but they fail too. This is a system that they left the water fill on with constant water coming in, constant fresh water coming in with calcium built up on the tube sheet on the top where the fire is, created hot and cold spots and cracked the tube sheet. This also happens with iron. The iron oxide or magnetite will do the exact same thing. Neutralize your condensate. For God's sake, please neutralize your condensate. We have measured condensate pH down to 1.6. This is extremely acidic. A beer is 5.2 and will erode the top right off a tile, take the concrete right off down to stones. That's 5.2. Muriatic acid is 0. We're really close to that, aren't we? You don't want to stick your hands in it, but look at that brass drain. This is amazing. I thought they cut the brass drain out to run their PVC down into it. Nope. That's 3 months after installation of dropping it down there. It has eroded a hole through a Jomar brass. Drive a fork truck over it. Floor drain. That's huge. Please neutralize your condensate and put your condensate down through a safe waste to sanitary. Do not pump it outside. Line all your chimneys. I had a chimney sweep come into my office one day and thank me. He thanked me because I was using a rule of thumb back then that said if your chimney with an 82% efficient gas boiler or 87% oil-fired boiler, we used to have this rule of thumb. If the chimney was in the center of the house, you never needed to line it. If it was one side exposed to outside, you don't have to line it. If it's 3 sides exposed to outside, you have to line it. Well, I can tell you this, there's a reason why on a gas atmospheric boiler, there's rollout switches. It's because we never clean chimneys. And there's so much condensation happening on in that chimney, no matter where it is, that all the wonderful sheets of masonry are dropping down in front of the flue, which is causing products of combustion coming back in the house, which is why there's rollout switches. Yeah, line your chimneys. They make them in kits, in lengths, in diameter, you know, and they even make them in polypropylene, flexible, in a roll for modulating condensing boilers. How lovely is that? Line your chimneys. Buy the kit, do it. Your barometric damper needs to be 18 inches from an elbow. Stop using screws and weights to make up for the flappy of your barometric damper. We used to carry T's at my first supply house that were 24 inches long with the T for the barometric damper at the far end. And people would tell me they don't have room for that. Well, here's the problem. If you're coming out of an elbow, fluid going through an elbow, the fluid going around the outside, whether it's air or water, needs to travel faster than the fluid on the inside, which means when it comes out of that elbow, it's twisting. You have high velocity and low velocity water all twisting, or fluid twisting. Well, that will make your damper go flappy. If it's 18 inches from the elbow, it will be nice and still, and you won't have to use weights and screws anymore. Follow the proper venting material and techniques and material. RTFM first, folks. If it needs galvanized, use galvanized. If it's a condensing boiler, don't use it. B-vent on atmospheric gas, all fuel for your oil fired. AL294C works for condensing in some of your copper fin tube. PVC Schedule 40, which will soon be probably taken out of the code. CPVC Schedule 80 fire rated, and polypropylene. Know it, because things like this just don't pass mustard anymore. Isn't that amazing? Oh yeah, venting with a concentric vent right next to a flue. Constant cross-contamination with this one, bringing the products of combustion that are going out the intake, and because they can't get away from there because the chimney or a wall's next to it, they're just recirculating back into the boiler. Yeah, this is great, huh? Nice little monitor, oil fired underneath the window. Yeah, lovely. 4 feet below window. NFPA 31, NFPA 54, read them, folks. I love this one. That's a wood fireplace vented out a window. Classic. Or how about this? Galvanized, because when they ran the PVC and the Schedule 80 CPVC down from above, they didn't line it up with the chimney, so they offset it with a piece of galvanized. I guarantee you that didn't last 6 months. Yeah, now you know why I was there. This is horrible. That's the exhaust sticking up on a 45 and the intake's on a T. You want to have a condensing boiler that's going to suck in water, and you want to have a vent that's going to get hot, or a place for kids to drop down stones like they did on this one. Do it this way. Follow the manufacturer's installation instructions, for God's sake. I love this. Oh, can't cross-contaminate. They're both facing the opposite directions. This is not by any boiler manufacturer's installation operation manual. This is just made up on the spot because he's been doing it for 40 years. Why would he do it different? Don't do it this way. It will cross-contaminate. Follow the instructions. And this one, both vents came out behind those bushes, and I said, you can't have that. It's trapping all the products of combustion behind the bushes. So instead of just moving where they were, they extended them up. They extended the exhaust up. And I guess that every year when that beautiful cedar tree keeps growing, they'll continue to raise them up. You can't make this up. Combustion air intake. From a friend of mine, Jim De Palma, works for Wales Derby, great guy, was nice enough to give me a visual on how much free air you need to use indoor air for combustion. He said if you have a 150,000 BTU boiler, you need 2 tractor trailers, 2 42-foot tractor trailers full of fresh air in the basement, open and free, no doors, no anything in between it. And now we take into account that we're super insulating all our houses and wrapping and putting windows that are so tight, nothing's breathing. I sit there and I've watched ashes be pulled from a fireplace when the boiler's running. How crazy is that? Please use outside air when you can. And if not, follow your NFPA 31, your NFPA 54 guides on how to do it. No manufacturer can break code. The answer. By the way, I want to hold an envelope to my head the way Johnny Carson used to when he used to do this. The answer is a combustion analyzer, a manometer, or for you novices, a manometer, and a multimeter. What's the question? What 3 pieces of test equipment must all boiler installers carry? There's no getting around this, folks. The day of not carrying a combustion analyzer is gone. You must have it. If you're still carrying a back rack, pink shaky for your CO2, get rid of it. Buy a new combustion analyzer. Build it into your fees. I know they're expensive. They're going to range in price from $500 to $5,000. You can buy the sweetest US made product for $1,500 with a built-in printer. Do it. It will save you time. And when it comes to a court of law, they won't pull somebody like me in and say, so the boiler blew up. What was he supposed to do? Or it got all full of soot and it's no longer working. They're going to ask me what tools you need to carry. As an industry expert, I'm going to tell them that's an industry standard for everyone to carry a combustion analyzer, a manometer, and a multimeter. And he's going to say to you, do you own a combustion analyzer? And when you say no, yeah, that's called lost lawsuit. Do annual maintenance. Sell maintenance contracts. This boiler, we were told, was defective. Can you believe that? Hadn't been serviced in only 11 years. Isn't that great? How many of you guys have gone out to an oil-fired boiler that hadn't been serviced for 6 years and it's taken you 4 or 5 hours to get through the soot with your soot saw and your vacuum to try to get the thing clean? Holy geez. Annual service contracts, maintenance contracts are like printing money. I hear all the time, oh, I don't have the software for that. Folks, you carry a smartphone. We carry smartphones today. Put in the boiler installation date that you did at the Joneses residence. And a year from now, send them a birthday card for their boiler with a reminder their boiler needs service. If you sell the contract, you're guaranteed to be there. If you don't want to sell contracts, send birthday cards. You can get a box of 100 for $5 at the Dollar Under store. Please do it. Troubleshooting your boilers. Folks, got to do it. Baking can't solve all our problems. That's what it's beer for. But simple troubleshooting. Step number 1, remove the thermostat, especially between December 26th and January 25th, because his daughter gave him a smart thermostat, and that meant that he had to install it. Otherwise, he's not a man. So he installs it. Well, now you have fighting transformers, or you don't have any power, and now all of a sudden the boiler's not working. Go upstairs. Don't even go upstairs. Disconnect the thermostat down at the boiler. Jump it out. I carry a toggle switch with 2 leads on it. I bypass the thermostat. Take it off. Put my own on. See if it works. Look for water or air in the wrong place. Yep. Air in the wrong place or water in the wrong place will do nasty things. And don't be a parts changer. I love it. I get at least 1 call a year from somebody who says, I've replaced every part on this boiler and it still doesn't work. What are you going to do for me? What am I going to do? I'll come out to your job site and do a little training, a little on-site training. We'll find out what's wrong with the boiler, or better yet, we'll find out what's wrong with the system to find out what's causing the problem. And last but not least, troubleshooting. Never listen to the homeowner's reason for why the boiler failed. They'll tell you everything. They'll tell you exactly what happened to it. I've walked into houses where there's been legal sheets of paper taped to the wall, 10, 15 of them, exactly what was wrong with the boiler. If they're that smart and watched YouTube that much, then they should fix their own boiler. Though I don't suggest it. It's like giving somebody a gun that doesn't know which end to point. Don't do it. Troubleshoot correctly. This one came to me because, well, they had gone through 3 flame sensors and 3 igniters, and I got a phone call saying, I must have had a whole batch of bad ones. Do I have any more? And I said, that's not the problem. I said, pull the burner door and let's see what's inside the burner. I got that. I got nothing. I said, call me later. He didn't call me. He texted me this picture. That's a bat inside of a burner that was preventing it from firing. Please do your troubleshooting correctly and don't guess about anything. So thanks for joining me for 40 and 40. That was a fun little trip down memory lane. I do appreciate it. I could write books on this, I'm sure. I probably should have long ago, but you know, my name's not Diane Hollahan. I don't think I have that talent. But if you have any questions, please feel free to call me or email me at skwheelan@ntiboilers.com or call me on my cell phone at 215-275-2162. If I don't pick up, leave a message, I'll call you back. With that, I'd like to say thank you very much for joining me, and I hope to see you at a convention soon.
See ya.